Waves of Sound class. We are going to be talking about the specific type of waves generated by sound and how it is produced. Okay, this class will also be in two parts because this topic is a little bit extensive. So we will begin the introduction now. Okay, we will have new concepts. We will be defining sound as the form of energy that we can hear, even though this is not a complete definition, because even if there is no one to hear, energy is still transmitted. Okay, have you ever heard a riddle that says, if a tree falls in the middle of a woods and no one is there to hear it, did it make a sound? Well, the answer is yes, it made a sound. Why? Because the tree fell and it had mechanical energy. And we all know by the law of conservation of energy that energy cannot be created nor destroyed. It can only be transformed. So that mechanical energy probably came from the wind blowing, and it was transformed into mechanical energy by the tree falling. Now, where did that energy go? It doesn't disappear. It becomes sound, acoustic energy. So, yes, it makes a sound even if there is no one there to hear it. Okay? Now, let's see. Since we are being specific about this type of wave, we are going to be specific about the names as well. Sound has a specific name for the crests and throughs. Remember, crest is the highest point of a wave and the through is the lowest point. Crests are called compressions in sounds and throughs are called rarefactions. Rare as in something weird, in faction. Okay? It is also written in your presentation. Now you have a little drawing showing how the waves of sound work. These are longitudinal waves, okay? That means the particles move in the same direction as the wave, okay? Now, we now know that sound needs a medium in order to move. If something were to make a sound in space or in a vacuum, we wouldn't hear it. And we know that thanks to a scientist named Robert Boyle. He made an experiment. He was the first one to make an experiment in the need for medium in a sound. Okay? What he did was he hanged a clock with an alarm from a thread, and then he used the machine to cover it and suck all of the air out of that space, and then he waited for the alarm to ring. Time passed and the alarm never rang because there was no air to transmit the sound. Okay, so he started returning the air little by little to that space, and when there was a small quantity of air, the alarm could be heard just a tiny bit. Okay, and the more air he was introducing to that space he had removed it from, the louder and the louder the alarm got. And that's how he discovered and proved that sound needs a medium in order to exist. Okay? Why? Because it needs particles to replicate the waves. Okay? As you were seeing in the presentation in the previous slide, there needs to be particles moving in order for sound waves to be transmitted. In your presentation, you also have a drawing of the machine that Boyle used to make this experiment. Now, the speed of sound. The speed of sound is something that we already know in this moment of history, but it wasn't always like that. Okay, from 1708 to 1709, William Durham first tried to find the speed of sound. He did that by making another experiment. He gave watches to some of his assistants. They were coordinated watches, and he gave them also pistols, okay? And he told them, you are going to shoot at this time, and then you are going to shoot at this time, and you are going to shoot at this time. And then he placed them, or told them to go to different locations separated by kilometers apart. Okay, so he waited at another location and waited to hear the sound. He recorded the time that the shoot was made and the time that he heard it. Okay, so he used the speed formula, which I hope you remember, to determine the speed of the sound. Okay, he subtracted the time he heard it from the time that the shoot was shot, and that time he used the distance that he was from each person and the time it took for him to hear the sound, and that's how he got the speed of sound. And it was pretty accurate for that time in history. Okay, later some more scientists decided to prove and see if it was right. They decided to control all of the other variables that could make an influence on the speed of sound, and they discovered that the only things that influence on the speed of sound were the density of the medium and the temperature, and also that the physical state of the matter also made an impact on how fast sound travels. Okay, in your presentation you have the exact measure for the speed of sound that we know of today, and also several different speeds of sound in different materials. And that's it for today's class. Tomorrow we will be talking about how we can hear sound and how it works inside of our ear. So don't forget to log in for the Facebook Live Q&A if you have any questions or to discuss about this presentation. Also, please perform the exercises that the presentation asked for. I hope you have a really nice day. Bye bye.